Not the answer, but let's go through it. Cosecant inverse. Cosecant is not on your unit circle, so you have to use sine. So we have to rewrite this in terms of sine. So we'll have sine inverse. When we're doing the inverse, you take the reciprocal inside. Inverse, reciprocal, inside. So I'm going to take the reciprocal of -2, which will become -1/2. Well, if we go to our unit circle, and we look at, maybe I'll just pull up a unit circle on here. If I still have one saved on here. Nope, that won't do it. That won't do it. Moments will do it. Right here. All right, so sine inverse of -1/2. I'm looking where sine equals -1/2, and that is right there. I thought several of us were going to fall for the B trap, because it does say 11 pi over 6, but awesome on the 15 of you that recognized, hey, that would go through parts where sine inverse doesn't live. Sine inverse is just here. So you have to go down -pi over 6. Because if this is pi over 6, then that must be -pi over 6. So your correct answer was A, -pi over 6. We'll go back to this one. I wanted to put these back to back. So this one says the cosecant of 3 pi over 4. So in this case, we would take the reciprocal on the outside kind of thing. So I'm looking for 1 over sine of 3 pi over 4. So in other words, we're looking for where sine equals, or where 3 pi over 4 is. We're going to look for that sine value, and then we're going to flip it. We're going to take the reciprocal of it. So if we look at our unit circle, get rid of all that crap I just put on there. We're going to find 3 pi over 4, which is right here. And our sine value there is square root of 2 over 2, but you're going to take the reciprocal of it. You're going to take the reciprocal of it. So this is actually going to be 2 over square root of 2, which you'd multiply the bottom by square root of 2, multiply the top by square root of 2. And then you'll end up with 2 square root of 2 over 2, which is just square root of 2. Any questions on either two of these methods? We have time to ask. Today's lesson is really, really quick. Yeah, Brian. We're at the 2 square root of 2. So cosecant isn't on our unit circle, right? So we have to use sine. Yep. So we're going to do 1 over sine of 3 pi over 4. Well, the sine of 3 pi over 4 is actually square root of 2 over 2. So maybe I should have written that out. I guess it makes them a little more. I do a lot in my head kind of thing. So this would be 1 over square root of 2 over 2, which equals 2 over square root of 2. So I think it probably would be better if I wrote that step out. Is that clear? Yeah. Okay, good. So once again, inverse, you take the reciprocal inside. You take the reciprocal inside. And maybe I should write the answer on there. -pi over 6. If you're doing a regular cosecant, you kind of take the reciprocal at the very end. It never happens inside the parenthesis. It happens at the very end. Once again, you should never take the reciprocal of an angle. Because if I take the reciprocal of this, we'd be looking for the sine of 4 over 3 pi, which isn't on our unit circle. Inverse, do the reciprocal inside. Otherwise, do that. Okay, the last one is arc cotangent of -square root of 3. Arc cotangent is not on my unit circle. So we're actually going to look for the tan inverse of 1 over -square root of 3. Get rid of that square root in the denominator, and you're looking for where tan inverse is -square root of 3 over 3. Reciprocal inside. Okay, now we're looking for tan inverse of -square root of 3 over 3. So we go back to our unit circle, and I find where it's -square root of 3 over 3, which is right here. here is the big problem with that angle. Let's make this a little bigger. The quadrants where they exist are So cotangent only is in quadrant 1 and 2. The angle I just found was in angle 4. So you have to either add pi to it, but I find it kind of easier if you just shoot your finger all the way across to here. So that is adding pi to it. And now I'm back in quadrant 2, which is 5 pi over 6. Questions on that one? I think our cotangent is probably the toughest one because sometimes you're looking for a value that actually isn't part of our cotangent. So once again, you kind of have 3 methods. First method, find where your tan inverse equals negative square root of 3 over 3 and shoot your finger straight across on your unit circle. Second way is just add pi to it because this would be negative pi over 6 plus pi would give you 5 pi over 6. The other method is to recognize that cotangent inverse is here. So just look for the negative square root of 3 over 3 in cotangent. All right, questions on any one of those 3? Yeah, Brian. It's going to be 5 pi over 6. Hey, we have a test on Wednesday. I guarantee there's a whole bunch of these on there. So if you're having questions, now's the time to ask. Okay. Since today's lesson is really short, let's go over homework questions. And before we go over homework questions, I want to make a couple adjustments to the homework. There was a couple small little details that were kind of off on the answer key, but most of you probably didn't even notice them. You probably missed one of them if you checked your answer key. So the first thing is, on problem number 1, on my answer key, I wrote cosecant when it obviously meant secant. You probably want to caught it because you just looked at your numbers and you're like, yep. Second mistake, though, was 100% a mistake. That was worth points. The second one was worth points, and that is the fact that on number 13, the tangent value was wrong. On number 13, you should have came up with the tangent value equaling 4 over 3 and not 4 over 5 because it would have been opposite of your alpha, which would have been 12 over 9, which is 4 over 3. So your tangent on that one was 4 over 3. And I think 3 people got the bonus points because they sent an email out almost at the same time. Remember, you get bonus points if you find mistakes. The other thing really wasn't a mistake. I just changed the problem. I didn't change it on my answer key. It was number 17. Number 17, if you looked at my answer key, I actually used square root of 7 over and square root of 3. I had changed that one. I changed it because I wanted one that you could actually do without your calculator. So this is one I could say you can't use your calculator on, but it's kind of the same problem. So I changed yours to square root of 2 and square root of 6. Because if you put it in, tan inverse of square root of 6 over square root of 2 is tan inverse of square root of 3, which is on your unit circle, which would be 60 degrees. So I wanted to put this one in, and I forgot to change in my answer guide, but something I can put on, you can't use a calculator on this. All right, you just have to use your unit circle on. Because the other ones you used your calculator for. All right, what questions do we have then? Yeah. 31. For 31. So for 31, you would draw a triangle, right? Let's kind of draw the same old triangle. And it's a 90-degree triangle. It says that your beta is 47 degrees. So let's make this 47 degrees. That would make this B, this A, and this C. Well, it says our A value is 3. So we just put a 3 in there. And then it says come up with your, I guess this would be my alpha. Come up with your other 3 bits of information. Well, first of all, your alpha is going to be an easy one. I always get this one right off the bat. That is 43 degrees. Because if one angle is 47 and one is 90, that one must be 43 degrees. All right, let's go ahead and find our B value. Let's find our B value. Well, if we're looking at this, if I'm looking at my B value, and I have that 3 value, and I'm going to look at the 47 degrees, or you could look at the other one. Well, 47 degrees and B is opposite, and 3 is adjacent to that 47 degrees. So we just have to use our tangent, because the tangent of that angle, or 47 degrees, is opposite over adjacent. Well, opposite is that B value. Adjacent is that 3. Multiply both sides by 3, and you get B equals 3 tangent of 47 degrees, which should be about, I ended up getting about 3.2. And now to get C, you could really do A squared plus B squared equals C squared. Or you could use, like, I guess, cosine. You could say the cosine of 47 is 3 over C, and then solve it that way. All right, other questions? Questions going once? Questions going twice? All right, just some pacing we have going on. Tomorrow we'll work on a review. You do have the review in your hand right now, but tomorrow you'll have the full time to work on it. My advice to you is at least start looking at it tonight so you know what questions you're going to have. Wednesday we have a test. Thursday I want you to bring those SAT prep packets you guys received. Because we have to offer you a day where you just work on them and ask questions. So that will be Thursday. You just work on it, ask questions on it. Friday we'll have a lesson. Monday we won't have a lesson because you have PSAT prep, something where you meet in like the cafeteria and they go over with Kaplan how to take a PSAT kind of thing. So Monday you won't have class. Tuesday we'll have a normal lesson. Wednesday you have PSAT stuff. So really we only have Friday lesson, Tuesday lesson, and then we have normal classes starting like Thursday, next Thursday. All right, questions on that? It's kind of all right, so we don't have a ton going on in the next 2 weeks minus this test. Okay, now let's go over today's lesson. Today's lesson is just application of what we just did yesterday. This is turning statements into triangles, and you look at your homework. Your homework is almost already has the triangles drawn out for you. So in fact, you can barely read some of them and you can get your answer. So don't overthink this. As long as you knew how to do the homework today, this should be a super easy homework, minus the last problem takes a little more in-depth thinking. So it says a wire 108 meters long runs from the top of an antenna to the ground. So I'm going to go ahead and draw that. So we'll say that's my antenna. I guess I'll put it there. We'll say this is my wire. We'll say that's the ground. So this is my antenna. This is that wire they're talking about. And obviously this is going to be the ground. All right, so we have a 108-foot wire. So we're going to just put 108 for our wire. If the angle of elevation of the wire from the ground is 42.3 degrees, then we'll kind of look down here. An angle of elevation is the angle formed by a horizontal line and the observer's line of sight to an object above. So when we're talking about angle of elevation, they're doing the ground up. So that's going to be your angle of elevation. It is going up. So this is going to be my 42.3 degrees. And that just says find the height of the antenna. Let's call the antenna A. Now, in almost all of these problems, all you have to do is look at the angle they named and look at the two sides that were given or asked. Well, I have 42.3 degrees. A is opposite it. It's opposite, and 108 is my hypotenuse. So we should think opposite, hypotenuse. What trig function gives you opposite and hypotenuse? Yeah, sine. So if I have sine of something, let's call it theta, that's going to equal opposite over hypotenuse. Well, in this case, I know my theta. My theta is 42.3 degrees. And that's going to equal my opposite, which is A, over my hypotenuse, which is 108. Well, we just multiply both sides by 108 to get rid of that 108, and we're going to have A equals 108 times sine of 42.3 degrees, which means take out your calculator and make sure it's in degree mode, and I'll give you a second to just do it yourself. So that was 72.7 meters about. Now the next part, they just talk about angle of elevation and angle of depression. We're not going to spend a whole bunch of time on this because, like I said, most of the word problems are already set up for you. Angle of elevation is basically when you're looking up. Angle of depression is when you're looking down. So if you have this person here, your angle of elevation is when you're looking up at the balloon. Angle of depression would be if you're in the balloon looking down at that person. Depression is going down. Elevation is going up. Well, one more quick problem. We have a skateboard ramp that we're building, and the base of the ramp is 12.7 feet, and the height of the ramp is 4 feet. It wants the angle of elevation for that ramp. So let's go ahead and make a triangle, because that's what a ramp's going to look like. It's going to look something like that. It's going to be pretty sweet. We've got a right angle. It says that the base of the ramp is 12.7 feet, so we'll put 12.7 down here. It says the height is 4 feet, and it wants to know the angle of elevation, so that is that angle there. In other words, what angle should we put that at for this to work out with a 4 feet and ramp? All right, so once again, we look at the angle, and then we look at the sides that were given to us. Our angles here, they give us an adjacent and an opposite. An adjacent and an opposite. So we're going to use tangent. Because tangent of an angle is going to equal opposite over adjacent. Well, they didn't give me what our theta equals, so we have to stick with tangent theta still. But they did say the side opposite theta is going to be 4. And they said the one adjacent to it is 12.7. Can someone tell me how to get theta by itself? Because it has to be theta equals something. I need to somehow cancel out that tangent. How can I do that?
The inverse.
What was it, Liam?
The inverse.
Take the inverse. Yeah, we're just going to take the inverse of both sides, which is going to look something like this. We're going to take the tan inverse of one side. I got to change that thickness. We're going to take the tan inverse of one side. So that's tan inverse of tangent of theta. And that's going to equal what I do to one side, I have to do to the other side. So I have to take the tan inverse of the other side. Which is nice because now our tan inverse and tangent are going to cancel out. Now we're left with theta equals tan inverse of 4 over 12.7. That is definitely not on my unit circles, so we're going to go ahead and plug that in our calculator. And you should come out with about, it doesn't ask for a specific rounding point, so we're just going to use about 17.5 degrees. That's it. That's all your homework is. Draw a triangle, know how to read it, know whether you're using sine, cosine, or tangent. So the hard part in these problems is just discerning what they're asking. But they all have a triangle involved. All right, questions for me? All right, you have the homework to work on, and you also have a review to start. Tomorrow we'll work on the review in class.